Hello there, geometry. I hope that, I should look at that camera, huh? I hope that test went just fine. We are now starting Chapter 8, one of the best, most relevant, wonderful chapters in the entire book. And I think it's actually worthwhile starting this off with a little warm-up. So go ahead, pause the video, do these 5 warm-up problems, and then check the answers as we go. Pause, flash, welcome back. All right, write a similarity statement comparing the two triangles. Well, of course, triangle ADB is similar to triangle EDC, right? The order matters, congruent angles have to be corresponding. When you need to simplify number 2, recall that the square root of 72 is really the square root of 9 times the square root of 8. So I'm trying to break these down into square numbers, and you could say, oh, really, the square root of 8 is the square root of 4 times the square root of 2. Okay, well now when I simplify this out, the square root of 9 is 3. The square root of 4 is 2. And the square root of 2 I can't do anything with. So when I simplify this out, 3 times 2 is 6. And I have a square root of 2. Similarly, for problem 3, this is really the square root of 9 times the square root of 3, right? 9 times 3 is 27, so it's just 3 square roots of 3. The last 2 problems here, I know you're really familiar with proportions, so I cross multiply here, and I get 5x equals 24, and I divide by 5, x equals, you can say 25 over 4, or you could say 4 and a fifth. Yeah, try that one, or 4.25. And last but not least here, this one, just recall that when you solve things raised to the power, the first thing you need to do is isolate the variable raised to the power. So I divide both sides by 2. I get x squared equals 25. And then take the square root of both sides. And I get x is equal to, well, really, there's 2 answers. Positive 5 or negative 5. The question that we're going to be addressing here in geometry land is, if I'm dealing with a length, it is only going to be the positive value, and the negative value is another kind of answer. All right, now that we've done this warm-up, we're looking at section 8.1 in your book. It's similarity in right triangles. So we've been building up to this point, and what we want to do is look at geometric mean to find segment lengths, and then apply similarity relationships to solve problems with triangles. Okay, so please take out your 3 triangles. That's right. You still need them. These are the 3 triangles that, ta-da, remember that? You made these? Yeah, sorry, I'm like looking at the wrong board there. So get out your 3 triangles. Now, you'll notice here that we created an altitude from this vertex perpendicular to the base. And the first theorem says that really what happens is you create 3 triangles that are similar to one another. There's a big one, right? Triangle ABC, a medium one, and a little triangle. Well, in order to help keep these things organized in your brain, I know one of my angles is a right angle. That means I've got another angle. I'm going to call it angle 1 and angle 2. And the reason that's so helpful is in the large triangle, I've got 1 right and 2. In the small triangle, I've got 1 right and 2. In the medium triangle, I've got 2 right, then obviously that has to be angle 1. And that's really important on the next problem here, because when it says, hey, write a similarity statement of triangle GHJ, and it's got this K point. Well, first of all, I know I've got a right angle, right? So let's just label, I'm going to say this is angle 1, this is angle 2. Therefore, through a process of elimination, that has to be angle 1, and this has to be angle 2. The reason that's so helpful is now it's like the letters don't matter so much. I'm always going to put them in the same order. 1, right, 2. So in the big triangle, triangle G, 1, right, H, J, 2 is similar to, let's do the medium triangle here. I've got G, triangle G is angle 1, K is right, H is 2. Similar to my small triangle, again, triangle H is 1, K is right, J is 2. Get that? You see how that plays out? I hope so, because now what I want you to do is try these first 3 problems on your worksheet. Again, step number 1, label your angles as either 1 or 2, and then fill in the missing ones. Be careful on problem 2 here, because there's something unusual. If these 2 angles are the same, what's a triangle that has 2 base angles that are the same? Very interesting. And then 3 looks a little more traditional. Okay, welcome back. Now the next concept we need to talk about is geometric mean. Now you're all familiar with an arithmetic mean or an arithmetic mean. Arithmetic mean, you add up all the values and divide by the number of values. Well, in geometry, it means you multiply those values together and take the square root. So what we're saying is it's the square root or the positive square root of the product of 2 numbers. So if I multiply a and b together, right, that's going to equal some value squared. So what this looks like here is the geometric mean of 2 and 8. Okay, well, the 2 times 8 is 16. I take the square root of that. That means it's just 4. I'm going to do the positive value there, all right? The next one here, 2 times 10 is 20. Well, 20 is really, again, if you want to prime factor it, it's 4 times the square root of 4 times the square root of 5, which means it's 2 square roots of 5. So this is an old thing. We've been practicing it for a while, but now we really need to have this concept down, because I want you to pause the video and try these 6 problems right here. Okay, now we are back to our right triangles here, and what I want to do is look at the similarity ratios between the small triangle here, the medium triangle here, and the big triangle here. Let me just label this too so you can see. So of course this is small, this is medium, and this is the big one, the large one. And if it's helpful, hold your triangles out, because you know you can actually compare these two. So when I look at small to medium, hey, I can write a proportion. What I want to do here is I'm doing this with some regard to h. So what I'm trying to do is build this into a geometric mean, because it's an easy way to solve for missing lengths, because I know there's a proportion. What in the world does that mean, Mr. Rising? Well, here we go. From the small to the medium triangle, they both have h in common. What does that mean? Well, if I take the short leg in the small triangle and compare it to the long leg, h, so I'm saying x over h. Well, if I compare that to the medium triangle, it's h over y. Well, what's so cool about that? It means that h squared equals the product of x times y. That's a geometric mean. Wait a minute, you're telling me this value here, the altitude squared, is the product of those two? And what I'm going to tell you is yes, that's true. Okay, now compare the small triangle to the big triangle. Well, it's a similar thing, but now what we're trying to do is say, hey, what sides are the same in both triangles there? Well, you're like, well, this side A, right? The hypotenuse in A, in the small triangle, is the short side in the large triangle. So hypotenuse over short equals hypotenuse over short. So hypotenuse over short in the small triangle is the hypotenuse over the short in the largest triangle. Well, when you do this, when you solve for this one, of course, a squared equals this short piece times the entire length. How interesting. And actually, on the medium to large, it's a similar property here, because when I compare these two, they both have this side in common, right? And that's really the hypotenuse of the medium over the long leg of the medium is equal to the ratio of the hypotenuse of the large over the long leg of the large. And so again, cross multiply, b squared equals y times c. Well, that's really helpful because I can use that information to solve missing parts of triangles, and that's what we're going to do in just a moment.